All right. We are into chapter 6, 6.1. The title is function algebra, but I want you to think adding, subtracting, multiplying, and dividing functions. Fair warning, I may have a cat jump on my lap at some point during this video. So since there's not a warm-up, just a quick little introduction to how these things work. So if I have two functions, that share the same set of inputs. So this is really important. They have to share the same set of inputs. So for example, speed of a car in seconds and speed of a baseball in seconds. All right, so this could be two functions. I could measure the speed of a car in seconds, and I could measure the speed of a baseball in seconds. And let's call the speed of the car of time t. And let's call, so that's speed of the car. And let's call speed of the baseball b of time t. All right, since they both use t as the input, I can do a bunch of different things with these functions. I could add them. So add the speed of the baseball to the speed of the car. And that makes sense. That's like you're riding a car, you lean out the window and you throw the baseball forward in the direction of travel. And that new speed is the speed of the baseball plus the speed of the car. So that's just b of t plus c of t, the outputs, but plus the outputs. And sometimes we put the b plus the c in a parentheses and then another parentheses of t. And this can be confusing, so it's fine with me if you always write it b of t plus c of t. You can subtract the speed of the baseball from the speed of the car. So that'd be c of t minus b of t, which we might write c minus b of t. And that would be like riding a car and then throwing the baseball in the exact opposite direction. And it's just subtracting one output from the other. In this section, you will add, subtract, multiply, and divide lots of functions that don't have any context, where it's just x's, and those x don't represent anything. But I am not going to multiply the car speed with the baseball speed because that doesn't make sense in context. But you might look at, let's see, the quantity of ice cream bars sold and the price of ice cream bars. Let's see, sold in a day, and the price of ice cream bars on each day. Right, so day is your input. What day am I looking at? How many am I selling? And how much does each sell? So we could go Q of X, where X equals the day, and P of X, where X equals the day. It wouldn't make any sense to add these two together. Quantity plus price, that doesn't make any sense. But what might make sense is multiplying them together. Q of X times P of X. That's going to be how much money you're making. It's the quantity times the price. That's going to be the revenue. right? So in this case, we still need the inputs to be the same. We don't actually need the outputs to have the same units. So if this is in number of ice cream bars, and this is in dollars, revenue here is in dollars. And that's fine. Or you could look at Q of X divided by P of X. I'm going to write that the other way. P of X divided by Q of X. That's the price per, nope, that doesn't make any sense. Like I said, I'm going to make mistakes, but I stopped and thought about it. And the thing I want to reinforce is it does not always make sense to combine functions using addition, subtraction, multiplication, or division. You have to think about, does it make sense in the context of the question? So instead, let's look at a different one. Let's look at the profit on hamburgers each day and the number of hamburgers sold each day. Now it would make sense to look at profit for each day and quantity each day. Now if I take my profit of X divided by my quantity of X, I get the average profit each day. And that does make sense. So although what we want you to do is in this section is mostly just do the arithmetic and the algebra correctly, the important thing to keep in mind is whenever you're combining functions, they need to share the same set of inputs if they are addition or subtraction, and if they are multiplication or division. If they're addition or subtraction, they really should share the same outputs, the same units on the output, because otherwise it doesn't really make sense to add or subtract. But if it's multiplication or division, they don't have to share the same units on the output because you're creating a new variable. So let's look at some examples. All right, I'm going to do something. This is 6.1, question 1, but slightly different. So the cost of watches in dollars is, let's see, there's going to be a base cost, $500 for the factory, plus a cost per watch, 20W, where W is the watch, number of watches. So C of W equals a base cost because you need a factory, plus the cost of materials for each watch you make. And the revenue, let's see, is going to be, this is often just a straight multiple, and you better hope it's more than what your cost was. So let's say the revenue is $30 per watch. So for every watch you sell it for 30. That's actually the price right there. Now I can come up with a new function, profit. And the profit is a revenue minus the cost, right? It's how much money you make minus how much money you spent. So if I want to make a table, and let's do, if you sell 10 watches, if you sell 100 watches, or 1,000 watches. So our cost is 500 plus 200, 700. Our cost of 500 plus 2,000, that's 2,500. Our cost of 500 plus 20,000, that's 20,500. Our revenue is 210, 30 times 10, 30 times 100 is 3,000. and 30 times 1,000 is 30,000. And our profit is revenue minus cost. So that is actually negative profit, negative $490. Here it's positive $500, and here it's positive $9,500. And that is how you can combine functions. And you see it makes sense because my inputs are the same. So it makes sense to subtract to create a new function. All right, moving on. Let's think about combining functions and domains. So the first thing I want to say is you can only combine functions where they share the same domain. Maybe one function has a domain that's all real numbers, and one function has a domain that's only positive numbers. And when you combine them, you have to take the smaller of the two domains. And the combination may also change the domain. So let's look at an example of that. Let's let f of x be 3x plus 1. Let's do 3x plus 6. And g of x is going to be the square root of x minus 3. Now I'll pick a different number, minus 4. Okay. So the first thing you might do is say, what's the domain of each? So this domain is all real numbers. This domain is square bracket from 4 up to infinity. So if I want to add f plus g of x, which is just adding the outputs, I can only do that when it works for both functions. So that's 3x plus 6 plus square root of x minus 4 when I'm in the interval from 4 to infinity. Even though I can put -7 in for x, I can't put it in for x there. So it restricts the domain. All right. Let's see. What about f of x divided by g of x? I'll write that again. F of x over g of x, that's equal to 3x plus 6 divided by the square root of x minus 4. And that's only true. Now I can't include 4 because that would make the bottom 0. That's what I mean. The combination may also change the domain. Any number can go on the top, but only numbers strictly greater than 4 can go on the bottom. So that actually makes my domain a little bit smaller. I could look at g of x over f of x, which is the square root of x minus 4 over 3x plus 6. Okay, so I can put 4 in again. I have to worry about this being 0. This is 0 if x is -2. But that's not going to be a problem because I can't get down to -2 anyway. So my domain is 4 to infinity. So combining functions and domains, you can only combine a function where they share the same domain. The combination of the function may also change the domain. And really, it's only ever going to change it if it's a division, because you might be dividing by 0. But just be aware of that. And it's okay to combine functions and take the intersection of the two domains. Let's do one more just so you can see what that means. F of x equals natural log of x. G of x equals the square root of 10 minus x. So the first thing to do is to think about those domains. This domain is everything greater than 0. And this domain, this is a good chance for us to review. If I'm putting something in a square root, it has to be greater than or equal to 0. So that means 10 minus x has to be greater than or equal to 0. I'll add x to both sides, so x actually has to be less than or equal to 10. So this domain is everything from negative infinity up to 10. So if I want to take f of x minus g of x, that's the natural log of x minus the square root of 10 minus x, but it only counts when I can use natural log of x, so that's 0 to infinity, and it only counts when I can take the square root of 10 minus x, so that's negative infinity up to 0, and if I put those, up to 10, if I put those on a number line just to help myself a little bit, here's 0, so log is this way, and here's 10, square root of 10 minus x is this way, and the part that works for both is there to there. So for 0 up to 10. Combining those functions is allowed, but it changed the domain to be restricted to match both of them, so that both pieces of the function can accept x. All right, moving on. All right, I'm just going to do a couple more function combinations. Let's see what we end up with. Let's take f of x equals x squared plus 2x, and g of x equals x plus 2. F of x times g of x is x squared plus 2x times x plus 2, which I can multiply out if I want. Let me just check my domains. This can be any number, this can be any number, so I'm okay. All right, so on all real numbers. F of x plus g of x is x squared plus 2x plus x plus 2. Again, this is on all real numbers. F of x minus g of x is x squared plus 2x minus x plus 2 as a quantity. That's something you need to make sure you're checking. And that's going to work on all real numbers. And as you might have guessed, the ones we have to worry about in this case is f of x divided by g of x, which is x squared plus 2x over x plus 2. So it only works if the denominator is not 0. So I have to cut out negative 2. Now you might notice that this formula could be just written as x, because x squared plus 2x can be factored into x times x plus 2. But this function x, even though it behaves the same as this function at every point except minus 2, these functions aren't the same. So the lesson is just don't simplify combined functions. And I think that's pretty intuitive if you think about my video screen is freaking out. So I have no idea if this is being recorded or not, but I'm giving it a shot. So if we go back to our example of our cost function, cost of W equals 500 plus 20W, and revenue as a function of W is 30W, and the profit we said was revenue minus cost of W, so that's 30W minus 500 plus 20W. Yes, you could certainly combine all that and say that's 10W minus 500. But I like it better this way because that makes it more clear that my profit function is built from two different pieces. And it helps me identify the different pieces as revenue and as cost. Same if we had let's say we have a cost function that maybe looks like 500 plus W, and I want my average cost. Well, average cost is just my cost divided by the quantity. So average cost as a function of W is 500 plus 20W over W. And I could write that as 500 over W plus 20. But this makes more sense to me because I say, okay, that's the cost of each unit and that's the number of units. So my advice is when you combine functions, no matter what they look like, just don't simplify it. If you're using them to answer questions, you might have to do a little more arithmetic, but you're going to have it locked in a lot better with what the domain should be and what the different pieces mean if you're doing a question in context. All right, and that's it.